Good to have you on SpaceX Daily, episode 23. I'm Patrick in Vancouver. Today is July 5th, 2026. From the launch pad to the trading floor, here's everything that moved today. Ship 40's completed static fire and a semiconductor testbed riding today's Falcon 9 both test hardware that must survive repeated thermal and vibration loads before scaling. Ship 40 completed a full-duration static fire, confirming the vehicle's 6 Raptor engines can sustain the burn profile required for the upcoming flight test. The test moves the ship one step closer to stacking and launch preparations at Starbase. Engineers will now review telemetry for any thrust vector or propellant flow anomalies before clearing the vehicle for flight. The result keeps the Starship campaign on its current cadence target. Remember, the show covered Starship on episode 22. Today's static fire moves that forward by clearing another hardware milestone on the path to booster catch and orbital refueling demonstrations. While Starship hardware advances on the ground, a routine Falcon 9 mission today tested an entirely different class of orbital hardware. 2 semiconductor manufacturing pods from Beskar Space Industries are manifested as a rideshare on the Starlink 10 to 50 Falcon 9 mission. The pods will operate in orbit to evaluate microgravity crystal growth and thin film deposition processes. Data returned will inform whether orbital conditions can reduce defect rates compared with terrestrial fabs. The test marks an early attempt to fly production-relevant semiconductor hardware rather than pure research payloads. The Falcon 9 lifted 29 Starlink satellites plus the Beziex semiconductor test bed from SLC-40. The first stage booster performed its usual recovery sequence after deploying the stack. This mission continues the rapid replenishment cadence needed to maintain global coverage density. The liftoff of the Starlink 10 to 50 mission from Space Launch Complex 40 is currently scheduled for 6:50 a.m. Eastern Daylight Time. The launch window and trajectory support both the primary constellation deployment and the secondary semiconductor payload. The mission profile calls for a southeast trajectory that places the Starlink satellites into a 550 km circular orbit. Recovery of the booster on the drone ship is planned, preserving the vehicle for a future flight. Several accounts highlighted the exact T0 timing of 6:50 a.m. Eastern Daylight Time and the expected booster landing coordinates on the drone ship. The same mission also carried a second, more ambitious orbital processing experiment that SpaceX disclosed this week. SpaceX disclosed the AI-1 satellite architecture, which integrates onboard processing hardware with Starlink's laser intersatellite links. The design targets orbital inference workloads that could reduce latency for Earth-based AI users. Details were released in regulatory filings tied to the company's public listing. Observers on X noted the unusual pairing of production semiconductor hardware with a routine Starlink deployment and are tracking early temperature readings from the pods. A separate thread discussed how the AI-1 satellite's disclosed processing nodes could interface with existing Starlink laser terminals for distributed inference. Launch watchers posted high-resolution photos of the transporter erector at SLC-40, showing the additional mounting hardware for the Beskar pods. Worth keeping an eye on, the semiconductor testbed remains an unproven manufacturing approach, whose yield improvements must still be demonstrated after recovery and analysis. Any contamination or thermal control shortfall during the short orbital stay could limit the data's usefulness for scaling decisions. Follow-on flights will be required to establish repeatability before investors treat orbital fabs as a material revenue line. On the AI front, SpaceX disclosed the AI-1 satellite design, which places processing hardware directly on orbit and routes data through laser intersatellite links already flying on Starlink. The architecture is intended to support low-latency inference tasks without routing every query through ground stations. From an engineering standpoint, placing semiconductor fabrication hardware in orbit removes gravity-driven convection and sedimentation that distort crystal growth on Earth. The Bexar pods therefore test whether microgravity can produce lower defect densities in thin films and boules, directly attacking the idiot index of terrestrial cleanroom energy and filtration costs. If the orbital environment cuts defect rates by even a factor of 2, the raw material floor for each finished wafer drops because fewer scrapped crystals are needed upstream. The Falcon 9 secondary payload slot keeps marginal launch cost near zero, letting the experiment run without dedicated heavy lift economics. Success would open a path to larger orbital foundries whose power and thermal constraints are solved by the same Starship-class vehicles already under test. And a quick market note. SpaceX closed at $162, up 2.6%. Before we go, watch for the first post-flight data drop from the BesX pods once the Starlink 10 to 50 stack reaches its 550-kilometer orbit. That covers everything worth knowing about SpaceX today. SpaceX is trading at $162, up 2.6%. A quick rating on Apple Podcasts or Spotify goes a long way. I'm Patrick in Vancouver. See you tomorrow. And before you go, this show is part of the NARA Network, a family of daily podcasts on tech, science, and markets. Each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Fascinating Frontiers, the most fascinating news from space and science. Find every show free at naranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.